Welcome to The Explainer. Okay, so today we are digging into the wild evolution that's happening in AI, like right now. We're going from these pretty simple chatbots to, well, complex autonomous systems that can basically act like a whole team of experts. It's a huge leap. So let's just dive right in.
All right, it really all kicks off with something I bet you've seen a million times. You ask ChatGPT a question and boom, that little message pops up, searching the web. Now that might seem like a small thing, but understanding how that actually works, that's the key to unlocking this whole new world of AI agents. So yeah, let's break it down.
Okay, so before we can even talk about how an AI can do things, how it can act, we have to get our heads around the part that lets it think. And that, of course, is the large language model. You know it as the LLM.
I want you to picture a pure LLM as this brilliant, super knowledgeable brain, just floating in a jar. Seriously, it's soaked up a mind-boggling amount of info from its training. So it can reason, it can explain things, it can write like a pro. But, and this is the most important part, it has no hands, no eyes. It's completely cut off from the real world.
So let's say you ask it, hey, explain this super complicated security standard. It'll give you a fantastic, detailed answer, but only based on what it already knows from its training. It's totally locked in that jar, remember? It can't go check a website for updates, it can't run a piece of code to see what happens, and it definitely can't peek into your company's private database. It's a pure thinker and nothing more. So that's the bottom line for this first step. The foundation for everything we're about to talk about is the LLM. It's just the brain, the part that thinks. Got it? Okay, because now we're moving on.
All right, now for the fun part. Let's see how we give that brain in a jar some hands. This is the first really big upgrade, where we turn our thinker into a doer.
So what's an agent AI? Well, it's pretty simple, really. It's what you get when you hook that powerful LLM brain up to a set of tools. And these tools can be literally anything: a search engine, an API to send emails through your Gmail, a code interpreter, you name it. All of a sudden, that brain can actually do stuff in the real world.
So for example, you could have an agent that uses a search tool to pull up the latest news, or another one that taps into the Gmail API to shoot off an email for you, or one that runs some Python code to crunch some numbers. But here's the key thing to remember. For now, it's always you, the user, telling it to do one specific thing with one specific tool.
And there you have it. That's the next step on our ladder. We've got the brain, and now we've added tools. So our formula is now brain plus tools. It can think and it can act. Seems simple, but wow, this combination is a total game changer.
Which brings us all the way back to that first question, right? When you see ChatGPT doing its thing, searching the web, what are you actually looking at? Is it just an LLM or is it an agent?
Well, the answer is it's kind of both. See, at its heart, ChatGPT is an LLM. That's its brain. But the moment you ask it something that needs fresh information, like what's the latest news or what's the current price of Bitcoin, the LLM realizes its own knowledge is out of date. So what does it do? It reaches out and activates a tool, the web search. And that behavior? That's pure agent AI. It's an LLM using its tools to get the job done.
Okay, hold on, because we're about to take another huge leap. We're going from an AI that just follows a single, simple command to one that can manage a whole project by itself. Seriously, this is where it starts to feel like science fiction.
This is what we call an agentic AI. And the best way to think about it is like a little autonomous employee. You don't spoon-feed it instructions anymore. Nope. You just give it a big, high-level goal, and it figures out all the steps on its own. It'll make a plan, take an action, look at what happened, and then, this is the cool part, it'll self-correct and improve its plan over and over, all in this continuous loop.
And this really gets to the heart of the difference. The agent AI we just talked about, it's reactive. It just sits there and waits for you to tell it what to do. But this new agentic AI, it's proactive. You give it the finish line, and it figures out how to run the race. It breaks the goal down into its own little to-do list and just starts checking things off, working all by itself until the job is done.
So just imagine this. You tell an AI, hey, I need a 10-page report on the latest AI security threats. An agentic system won't just do a web search. No way. It will plan out the report's sections, then go search for sources, read those sources, summarize the important bits, write a first draft, and then, get this, it'll even review its own work to find mistakes. All of that completely on its own. It's not just performing an action, it's managing the entire project.
So, if an agentic AI is like one autonomous employee, what do you think is next? What happens when one isn't enough? Well, you build a whole team, right? A team of AIs to take on even bigger, more complex problems.
And this brings us to agentic orchestration. Think of it like an orchestra. You've got a conductor agent, who's like the manager, and then you have a whole team of specialist agents. Each one is an expert at one specific thing. The conductor's job is to coordinate all of them, making sure they work together in harmony to achieve some really complex, multi-step goal. A perfect example would be an automated security analysis system. You'd have one agent whose only job is to scan application logs. Then, a second agent, a specialist, checks for really specific threats like prompt injections. A third agent comes in and scores the risks based on industry standards. And then a final agent takes all that work and writes up a clean, easy-to-read summary for the human security team. They all work together like a well-oiled machine, with the conductor making sure the final report is perfect.
But how does all of this actually work under the hood? I mean, how do these systems get the right knowledge, and how do they physically connect to all these tools? Well, there's a secret sauce, and it comes down to two key pieces of tech.
You're going to hear these acronyms a lot, RAG and MCP. Let's start with RAG. That stands for Retrieval-Augmented Generation. Just think knowledge. RAG is what lets the LLM look outside its own brain and pull in specific external info, like your company's private documents or the very latest medical research. Then you have MCP, think action. This is the protocol, the framework, that actually gives the LLM the ability to use tools, call APIs, and run code. So RAG is for knowing, MCP is for doing.
So here's the absolute simplest way to lock this in. The LLM, that's the brain. It thinks. RAG, that's the special library it can go read from to get fresh, specific knowledge. And MCP, those are the hands and the tools it uses to actually get things done in the world. Brain, library, hands. Got it?
Okay, we have covered a ton of ground here. So let's zoom out and look at the big picture one last time, putting it all together.
So here it is, the whole evolutionary ladder. We start at the bottom with the pure LLM. That's our thinker. Then we bolt on some tools and we get an agent AI. That's our doer. We give that doer a goal and let it run free, and we have an agentic AI, our autonomous worker. And finally, at the very top, we put a bunch of them together to get agentic orchestration, a full-blown AI team.
And really, that's the key takeaway from all of this. We are fundamentally shifting from a world where we just ask AI simple questions to a world where we can hand it an entire job. I mean, think about that. This progression from a lone thinker to a fully coordinated team, it just blows the doors wide open on what's possible. The problems we can now ask AI to solve are on a completely different scale. And what happens next? Well, that's going to be interesting.